Good afternoon, everyone. So, I submitted this talk some time ago, and Dancing on the Head of a Ping. I thought that's a really good title. And then as time got near, I thought, you know what, that's actually a really terrible title. And given recent events and film releases and everything else, we decided to subtitle it There and Back Again, an Echo Reply Time. So, I'm Ian Norton of Shadowcat Systems, based in Lancaster in the northwest of the UK. And that's from a different presentation. That's an interesting note. So, I'm talking about building a software as a service monitoring platform using OpenNMS. So, what we basically did was we took OpenNMS and we added additional stuff on top of that to integrate different bits and pieces to try and simplify the UI and, yeah, just kind of layers on top. For you guys, we're probably not really adding an awful lot, but you're not our target audience for this service that we're offering. We're also aiming to automate as much as possible to make safe assumptions and try and reduce the amount of user input and hide some of the complexity from the end user. So, our OpenNMS hosting, mentioned earlier that OpenNMS needs 8 gig. We're running 2 instances of OpenNMS within 2 gigs of RAM. The storage is, I think, about 25 gigs each, and it's running Debian and Wheezy. Tom's just talked about Ansible, and his presentation notes will be available online after the conference, and Postgres and OpenNMS 1603. So for those who missed Tom's Ansible talk, there's the URLs again, just in case you missed it, or you can catch them on the presentation video. So we build our OpenNMS instances to live in about 15 to 17 minutes, which is pretty good. So now, why 2 instances is the interesting question. And the reason is that we're splitting discovery aspects of OpenNMS onto a separate node, and then actually using the other node for monitoring the actual services. And we'll explain as we go through as to why we're doing that. So, talking about the front end, in terms of what I'm going to show you, screenshots and things like that, the device is basically an OpenNMS node and a benchmark is an OpenNMS service. So, with that in mind, we can add a new device, which we give it a name and an IP address. And then we chuck that in our database. Now, by far the best and most comprehensive service discovery of all the network monitoring platforms I've ever looked at, OpenNMS outclasses anything else. And SNMP functionality is just fantastic. So what we do in our database is we set a little flag on the record that says that the node needs to be scanned. And what we then do is we generate an OpenNMS provisioning requisition using PRIS, provisioning integration. And then we watch events on that discovery node to see what services are found. So PRIS will take any set of data sources, database spreadsheet, CSV file, whatever you want to chuck at it pretty much, and it will generate a provisioning requisition. And you can include in that categories for the node and everything else. So that's actually really useful and saves a lot of time. Marcus is talking tomorrow about PRIS at 2 o'clock. If you've never heard of PRIS, don't know what PRIS is, I encourage you to attend because it's a fantastic piece of software. So on our discovery node, we're using the REST API to look for completed events. So scan complete, node scan completed, and then we create benchmark records in our ShadowNMS database so that we know what capabilities a node has. And that then enables us to ask the user, sorry, you taking a photo? That then enables us to ask the user which services they want us to monitor. So Heartbeat is ICMP, web server is just HTTP, SSH, and websites is something we'll come on to in a bit. So once again, we can push that live with some more PRIS. Honestly, Marcus is talking about this 2 o'clock tomorrow. Learn awesome things and sync them. So once we've done that, we can pass that out to our monitoring node, and that allows us to actually put that into a monitoring production. The reason that we split those nodes into 2 is because our discovery node has a data retention time of, I think, 1 day. So there's very little data on that discovery node. The retention is low, there's very little on it. And we're purely using it to do the discovery components. And then obviously the production one that's actually doing the monitoring has got a lot more data on it and actually is where we're retrieving data from. So we can collect the node ID from our production monitoring box and we can pass that back to the Shadow NMS database. Then we can retrieve outages via REST, which allows us to identify which nodes are up and which are down. But actually, we only want to do that for the organization that the user's logged into as, because Shadow NMS is actually multi-tenant. So we use asset information on the node to add the ID of the organization that the user belongs to. And then we can filter on this. And we end up with this, which is for org ID Cthulhu, which is just there, just in case you can't spot it. So, for anybody who's into role-playing, lose your first sanity point. Seth is talking about enhanced REST searches in his next talk. So, stick around in this room and you can see that, and I'm sure that Seth will be showing us equivalent horrors. So, we can then actually retrieve our outages from that URL via REST, and we end up with this nice traffic light simplified UI, which gives us a red, amber, green status of all the devices. In this case, Tom's web server has lost his HTTPS, I think. I don't know. I didn't even break it intentionally. So, what's involved in all this shininess? Well, there's lots of Perl. Anybody who knows Shadowcat, knows us, knows me, knows that we do a lot of Perl. So quite a lot of our stuff is glued together with Perl. And we're using Catalyst Web Framework, which is Perl. Then we're using AngularJS and Bootstrap, which talks to JSON API endpoints using Catalyst. And there's Postgres under that, which is underlying everything. So to give you an overview, that's how the whole thing fits together. So this is kind of a high-level overview. So we've got our clients talking to our AngularJS Bootstrap, which goes into Catalyst, which talks to Postgres, which generates configs using PRIS, and then we've got our 2 OpenNMS instances, each running Postgres database, and holding it all together with scripting. So, what services are we running within that? At the moment, we're only actually monitoring a small subset of things. So it's fairly limited at the moment. However, as time goes on, we're expanding that. And there's bits and pieces I'll talk about. So having run this for a little while, we had a number of users. And one of our partners, who's been doing beta testing for us, went, "This is fantastic," and threw a load of stuff at it. And we thought we'd leveled up. Sadly, failure is always an option. And this is Moggles. And Moggles presents himself occasionally via the web UI to say, actually, we haven't got any data for you. So the first thing we encountered was PRIS spoiled our day. And I had a chat with Marcus about this afterwards, and he said, yeah, I knew about that. So we pull from PRIS every 5 minutes, and each time we get 4 events. So the importer starts, then for every node in the PRIS thing, there's a node updated and a scan completes for every node, and then there's an import successful at the end of it. There's 288 5-minute slots in a day. For each of those 4 events, there are about 300 nodes. So 345,000 records a day in a 24-hour period. That's about 2.4 million records a week in the events table. At some point, we think it was about 5 million, but there was some debate on this last night over a pint. We're not entirely sure because we're in two minds as to whether we actually dropped the table and recreated it. But OpenNMS started to slow down a bit, which would be a bit of an understatement, and it really spoiled our day. And what we did was we took about 8 hours to delete those records, as I recall, because the database was so badly wedged. So we deleted all those records and everything was good. And then we changed these 3 records here to a do not persist strategy because we thought that might be a good plan. So they're no longer being logged in the database. They appear in the web UI, which is always handy for debugging, but obviously we don't really care about them in the database. There was much wailing and gnashing of teeth. So this talk at this point is mostly about fail and experiences we had. So website monitoring was the next thing we decided that actually it'd be really cool to do website monitoring. But we don't really care about the IP address, do we? And certainly the customers don't care about the IP address. What they want to do is they want to enter a URL and have it go off and work out from DNS what the host is and go retrieve the data. They don't actually care about the IP address. If they move it around, then it should just work. I have a specific use case example of this, which is community sites where we don't actually control the DNS. So the Perl Foundation and the Enlightened Perl Organization and various other people, we've had instances where things have moved from one host to another, and those updates might not necessarily come through to the people who are monitoring that to make sure it's working. So if you can do it by host name, then who cares if it moves as long as it keeps working. So if we want to monitor by name, OpenNMS absolutely does care about IP address. So how do we do this? Page sequence monitor allows you to do this. So Marcus and Jeff gave us some pointers and helped us sort this out. And so we ended up with a page sequence monitor. And page sequence monitor allows us to monitor the website based on the node label. So we ended up with another provisioning requisition, and our second provisioning requisition, technically our third provisioning requisition, generates just website monitoring. And that's it, that's all it does. So each website becomes a node in its own right, and voila. So the magic happens just here, if anybody's missed that. Problem is, OpenNMS still cares about the IP address. Technically, it doesn't need it, but it does because all of the data is indexed by IP address. So the data for the RRD files is indexed by IP address. Let's fake it, we said. So IPv6, that's a good idea. It's got loopback addresses. So we used FE80::, and we took the ID of the website from the database table, and we used 2 hex on the ID to generate an IPv6 IP address based on the IP, so based on the ID in the database, which is particularly nasty. But it works. Mostly.
You're not supposed to tell them when the bad programmer took.
So, pretty graphs. Pretty graphs. So we've done all this stuff, and it's wonderful, and it's working, and it's IPv6, and it's horribly kludged, and nobody's really looking. It's all buried underneath. And you should never underestimate the pointy-head boss who says, I want pretty graphs, mentioning no names. So, Tom found a fantastic graphing library using N3 chart, which is based on D3.js. And it produces really pretty graphs. And we can pull all the data for these pretty graphs from the REST API. You know, I mentioned we're using IPv6 node addresses for those websites. Well, the REST API is broken for IPv6, so you can't get any IPv6 data out. So we think we found the problem and we logged a bug, and we think it's fixed in 1604. So when 1604 comes out, we'll check on that. So we ended up implementing a microservice just to export that RRD data, using a JSON API to provide a REST endpoint to be able to pull that data out of the RRD file. So again, we just bury that underneath. Nobody will notice. So pretty graphs. We've generated our microservice for our RRD data export using our JSON API with the REST interface to RRD tool. It's a short-term fix, but we might actually keep that service there because there may be other things we can actually use it for. We're not entirely sure yet, but at the moment it's an interesting shim layer just to solve a short-term problem. And it does allow us to produce quite nice graphs. And this allows us to actually have multiple axes of data on this graph, as well as just one axis. And also, it's because it's a JavaScript library, you can actually pick that up and expand it, shrink it, zoom in, all on the fly. And that's a single data request. So once you've got the data to the client, all of those operations actually happen on the client. So it's really, really quick as well. This is actually really nice. So the next thing we moved on to was notifications. And we want to actually do email notifications, IRC, Twitter, XMPP, and possibly Slack or Telegram or Snapchat or whatever the cool kids are using now. But we don't want to have to configure users for every user in Shadow NMS. We don't want to have to configure a user in OpenNMS that we can email. So actually what we want to do is when an outage happens, we want to email all the people who said they want notifications in an organization if the node that's gone down has notifications configured. So combination of categories and bits and pieces. We thought, okay, we've got about approximate solution to this problem. But we can't actually set the target address. My best efforts of evil using Exim and address rewriting on the fly using database lookups and all sorts of nastiness failed. And Marcus is saying, I told you it wouldn't work. So we kind of gave up on that and said, okay. So I smacked my head against my desk several times and moved on. So what other notification capabilities have we got in OpenNMS? Well, we can send notifications via HTTP, which is really quite sweet. And you can use a GET or a POST. And I had a chat with Jeff earlier, and he said, yeah, we're thinking of deprecating that. So it looks ideal, but we experienced some oddness, shall we say. And the main oddness is that if anybody's got OpenNMS configured to send email, you'll notice it sends you an email saying outage, blah, and when it recovers, you get a recovery notification. That second bit is where the oddity lies, because when the event resolution happens, we get a timestamp of midnight, and we get the severity of the original event only as a number. So if the severity of the original event was critical, we get a second notification of 7. So the severity comes back through as 7. Are those numbers right? Critical 7? I think they are. But it's still got the same event ID, so we can work with that. We're not entirely sure what the correct behavior is. So I kind of discussed this on the mailing list with a few people, and and IRC, and we're not entirely sure what the correct behaviour is. So that's more of an oddity. But we've worked around it just by taking the event ID and checking the database to see if the event already exists, closing the event based on the current timestamp, and that mostly works. Although a little bit edge casey and odd. So at some point, if we manage to work out what the correct behaviour is, we might file a bug on that. But so other issues with provisioning is if you're adding nodes via PRIS using provisioning, how do you remove those nodes when they're no longer required? So in our discovery node, we're adding nodes a lot, removing them, adding them, removing them, adding them, removing them. No power supply. So the workaround for that is that we can actually remove those nodes via REST API, which actually neatly fixes that problem. We haven't quite got round to that yet, but it's actually an interesting little quirk that we came across. So everybody's very, very quiet and serious. If anybody wants to ask any questions, that'd be good. Because otherwise I'm going to run out of material real soon now. So, in the future, there's lots of features of OpenNMS that we've not necessarily implemented within Shadow NMS. Things like, currently we're not doing any SNMP data retrieval, which is one of the reasons we chose to use OpenNMS. We're not doing things like thresholding based on high throughputs or high delays and things like that, which is all things that we want to add, but we haven't quite gotten to yet. So, in terms of the future, we're currently working on some Phantom.js, which is website profiling, which allows us to have a microservice which we're calling into to actually go off, retrieve a pile of data. At the moment, we can see no way of incorporating that into OpenNMS because the capability to store the kind of data we're getting back doesn't exist within the current engine. There's no way to store that data in an RRD file or within the database as events because of the kind of data we're retrieving. So given a web page, how much time is spent retrieving HTML, how much time is spent retrieving CSS, JavaScript, images, what's the biggest image, the kind of data structure that's there, just we can't represent it. So we're looking at different ways of doing that. And I think, I'm hoping that maybe when OUCE comes along, there might be some capability of actually doing that kind of ad hoc data structure a little bit better. SNMP is definitely on the shopping list of things that we want. We'll be using categories to actually classify bits of the SNMP tree that we want to add to retrieve from a given piece of kit. Distributed monitoring, because we're not actually talking, the user is not talking directly to OpenNMS, it's talking to Shadow NMS. It doesn't matter if there are 12 OpenNMS instances at the back of that, because we're proxying through. So from our point of view, we can include distributed monitoring at fairly low cost, because which OpenNMS instance we go to retrieve the status of a device doesn't matter to the user. That capability is kind of there, but at this point it's not implemented because we didn't need it straight away, so we've kind of prioritized it as something we'll come to when we need that capability. But that proxying capability gives us interesting capabilities with website profiling as well, because we're not going directly to OpenNMS. The fact that OpenNMS can't store the data necessarily means that we can actually retrieve that data from the microservice. So that's less of an issue. I'm really excited to see what happens with Minion next, and I'm really keen to give that a try when that comes in, because I think that's actually really exciting. And that will actually do a lot of intelligent stuff without us having to implement it manually. So I can see Seth's argument for saying having multiple instances of OpenNMS doesn't give you a single pane of glass, but yeah, it's kind of looking at it from the other point of view, it's possible if you're using the REST API and you can proxy through to the OpenNMS instance, but it's kind of icky. So there's more cool things in OpenNMS that we're not implementing, that we absolutely want to. And the other thing that we want to do is that we want to actually make sure that we're porting some of the work that we're doing back into OpenNMS so that the contributions can go back into the main branch. So notifications, how we're actually handling the notifications of the HTTP notifications at the moment are being done as a microservice. So that microservice is something that we're looking to see how we split out so that we can have that notification service as a separate contribution, a separate open source project effectively that will allow notifications to go into that to then go off to other services such as email or IRC or whatever. So that sort of thing. Questions?
How much work did you put into cutting various content files to get the footprint down to run in 2 gigs of memory?
Not a massive amount. We disabled services. So the question was, how much work did we put into gutting config files to reduce the footprint of OpenNMS in order to fit it into 2 gig of RAM? And the answer is not a massive amount. We disabled services that we didn't need. So things like reporting. We're not using reporting currently, so reporting's been disabled. There's not a massive amount of work gone into that. We've had some issue with PRIS falling over due to RAM. So OOM has killed PRIS. But that's running on the same node as the Discovery. Because we're not monitoring very much, the footprint has come down. We've changed the default configuration for the memory limit, probably to bring that down to about 500 meg. And I think anything lower than that and it just won't run.
I'm not sure about 16, but I think some earlier versions was enabled by default or something.
Yes, yeah. Yeah, so that was, I can't remember exactly what I disabled, but I went through and just picked off things that were obviously, so linked reporting. I can't remember what else I knocked off. I'd have to actually go and look.
There's another one, I don't know how much of a thing that is in newer versions. Seth might correct me on this, but on the earlier versions, if you went through the global include file for the event definitions and just got rid of all the vendors you didn't have any equipment from, that would make a big difference at least in startup times and memory footprint.
Oh, that's interesting. So the comment for the video was that if you go through the events configuration, you can remove specific vendor extensions for events, which reduces your memory footprint as well, which I didn't know. That's actually a really neat comment, because that is an issue for us, is startup time.
I would imagine with 2 gigs of memory for startup and memory in general would
Yeah.
you don't need those anyways, it's not going to use any.
No. No, so SNMP capabilities is not there at the moment, so actually getting rid of those doesn't actually lose us anything at this point. So the other approach we're taking is, because we're looking at very small virtual machines as a first instance, we can actually increase the RAM on those as we need. But also we've got the capability to just shard and add another machine, so we bring up another machine. So the small machines from Bytemark are actually very, very low cost. Which is kind of trying to bring the service in and establish viability of the product as it stands. So we've tried to keep the costs of actually running the service down as much as we can, hence the reason we're running in 2 gig of RAM. So.
Yeah, I can confirm that the VenCon content, I think all of the string content gets loaded into memory on startup. During profiling, I think is like 100, 150 megs. So that's been a while, maybe a year and a half since I looked at that. So
Okay, so.
it does take up a lot of room. If you can get rid of it, definitely do if you're RAM constrained.
Okay, so Seth's comment again for the video is if you remove the unnecessary event configuration from the event configuration, So vendors you don't need. Last profiling that they looked at was around 150 meg, but this is about a year ago, did you say?
I think so.
Yeah, so a year or so ago, that was about 150 megs worth of RAM footprint that can reasonably be removed. So thank you. I didn't know about that. Cool. Marcus?
So are you planning, what's the next feature you would actually like to add, and why aren't you adding, or why aren't you utilizing the reporting engine at the moment?
So what's the next feature we'd like to add, and why aren't we using the reporting engine at the moment? So the next feature we'd like to add is we'd like to get to the point that the website profiling is working 100%, because at the moment it's still kind of, the functionality is there, but it's not incorporated into the UI yet, which is something that we'd very much like to see. And the other thing is notifications. So notifications, we've got kind of 90% of the way there, but the notifications are not actually being sent out yet. So that's the other thing. Reason we're not using reporting at the moment is that we've not really got a need for it at the moment. So at the moment, we're only presenting this, this UI to the client, and not a lot else at the moment. We'd like to see reporting, and we've spent some time looking at Jasper in the past as to how to generate nice-looking reports that we can email to the clients. But that's kind of fairly low on the priority list at the moment, and we're only doing this kind of instantaneous view of things at this point. So.
You mentioned that you use two instances of OpenNMS for different purposes.
Yep.
I have a similar use case in my company, and my question would be, is it possible to install two instances of OpenNMS on one machine, pointing to different databases, or is this?
So the question is it possible to install two instances of OpenNMS on the same machine pointing at different databases? The answer is, I don't know. I suspect the answer is probably yes, but I don't think I'd want to try it.
The ability to run two at the same time?
Yeah, I mean, my thought was that perhaps our approach has been a little bit overkill, and maybe the correct way of doing things would have been to do it as different provisioning requisitions with different different Polar packages, which would be the other way of doing it. So if you use different Polar packages, obviously allows you to set the data retention time differently across different Polar packages. So that might have been a better way of doing it retrospectively.
My goal would be that one machine would do only the data collection topic, and the other one will only do the discovery. So I would separate the functionalities of the OpenNMS on two instances.
Yeah. Yeah.
If possible.
It's within the same machine having two OpenNMS instances. I'm not sure I'd want to try it. You'd need a lot of RAM, definitely, and I'm not sure what the interesting outcomes of processor contention would be. But I guess it's possible. I mean, the other way of doing it would be to virtualize and do small virtual instances, one for the monitoring and one for the discovery. But yeah, I mean, we had a very, very specific reason for, we wanted to do one machine which was dedicated to OpenNMS that was not contended to do anything else for our actual production monitoring. The other box has OpenNMS. Obviously, both of them have got Postgres. But the front-end box is actually running Apache with the Catalyst front-end, and a pile of other scripts and bits and pieces that do integration. PRIS is running on the front end. So the reason for keeping it very much separate was so that we could actually kind of limit the footprint of one whilst giving more to the other. Excuse me. Any other question? So, the Conan the Barbarian quote, what is best in life? To crush your enemies, to see them driven before you, and to hear the lamentations of their women, or lamentations, I'm never quite sure. What is best in OpenNMS? And absolutely what is best in OpenNMS is the community. That's you guys, all of you. And that's what makes it such a wonderful product and such a great piece of kit to work with. And I'd just like to give special thanks at this point to Jeff, Marcus, Ben, Keith, and the guys from the OpenNMS group, and hash OpenNMS on Freenode, which is a really, really, kick and cool place to be. So hang out in OpenNMS and come say hi. If there are no other questions, I'm pretty much done. Which is a little premature, but you've all got loads of questions, right? Cool. Thank you very much. If there's a conference survey, don't forget to fill it out. I don't know if there is or not.
There is.
Fantastic. There you go.